Hey everybody, this is Nick from First Coast Math Clinic. In this video, I'm going to show you how to solve systems of inequalities by graphing. Let's get into it. So for our first system, to graph these, we're going to use slope-intercept form to graph both of our systems. And the only difference is in slope-intercept form, we have an equal sign compared to an inequality here and here, but our slope and our y-intercept are in the same location. So we can still graph them as if they were in slope-intercept form. So we've got y is less than or equal to negative x minus 2. Our slope is negative 1 over 1. And our y-intercept is negative 2. I'm going to graph this in red. So we're going to start at negative 2 on the y-axis. And from here, I'm going to go down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1. And since this is greater than or equal to, I'm going to have a solid line. I'm going to go back to the left. Now we have to figure out where are we going to shade? Where is our solution set? Where are we going to shade for this line? Should we shade to the right? Should we shade to the left? And an easy point to test to figure this out is going to be 0, 0. If 0, 0 is true, we want to shade to the right. If 0, 0 is false, we're going to shade to the left. So let's test 0, 0. So I'll have 0 is less than or equal to negative 0 minus 2. And I get 0 is less than negative 2, which is true. So we're going to shade to the right. So let me clean this up a little bit. And I'll shade this in yellow. And for the bottom inequality, I'm going to do this in green. We've got y is less than or equal to negative 5 over x plus 2. Our slope, negative 5 over 1. Y-intercept is 2. So let's start at 2 on the y-axis. 1, 2. So we're going to go down 5, right 1. 1, 2, 3, 4, 5 over 1. And then to get a point on the left side, we can reverse that. I'm going to go up 5. 1, 2, 3, 4, 5. Back 1. And again, since this is less than or equal to, we want a solid line. Now we have to figure out what direction are we going to shade? Are we going to shade to the right or are we going to shade to the left? An easy point to choose, again, we've got 0, 0 right here. If 0, 0 is true, we can shade to the left. If 0, 0 is false, we can shade to the right. So let's test that in our inequality. We get 0 is less than or equal to negative 5 times 0 plus 2, and 0 is less than or equal to 2, which is true. So we're going to shade to the left. So we're going to clean this up a little bit. And I'm going to shade this in, we do this in light green. Now we have to figure out, well, we've got this area in yellow, we've got the area in green. Where is our actual solution? Our actual solution is going to be where these two overlap. And they overlap right here. So this section in blue. The section in blue is going to be our solution set. And if we wanted to test that, we can basically take a point that's in this solution and substitute it back into our system and make sure that, and basically and test those points. So let's test a point in the system. So we've got -1, -2, 1, 2, 3. Let's do that. So the test point, -2, 3, that's going to be for our check. So again, this point in our solution set, -1 and -2, 1, 2, 3, right here, -2, 3. So let's check that. Let me clean some of this up. So this is our check. Again, we're using -2, 3 in our inequalities. So that's our x value, that's our y value. Let's try our top system for our top inequality first. So we're going to have 3 is greater than or equal to -2 minus 2. 3 is greater than or equal to 2 minus 2. 3 is greater than or equal to 0, which is true. So this point checks in the top inequality. Bottom inequality, we're going to get 3 is less than or equal to -5 times -2 plus 2. 3 is less than or equal to 10 plus 2, and 3 is less than or equal to 12, which is true as well. So this point checked in both the top and bottom inequality. So our point checked from our solution set. All right, let's move on to example number 2. So for example number 2, our top inequality, x is less than or equal to -3. So if we graph this, I'm going to graph this in red. So let's find -3 on our x-axis. We know it's less than or equal to, so we're going to have a solid line. We know that this is going to be just a vertical line here because x is equal to -3 would just be a vertical line at -3. Now we have to figure out, well, where is our solution going to be? Well, if it's x is less than or equal to -3, well, where are my values less than -3? Well, those are all values that are going to be to the left of -3. So I want to shade to the left. So I'm going to shade that in yellow. So that back in. And our bottom inequality is y is less than 5/3, x plus 2. Our slope is 5/3. Our y-intercept is 2. I'm going to graph this in green. So we're going to start at 2. We're going to go up 5 and right 3. 1, 2, 3, 4, 5. 1, 2, 3. Since it's just less than, we're going to have a dashed line. It's not equal to, and to get the points on the left side, I'm going to reverse that slope. Instead of going up 5, right 3, I'm going to go down 5. 1, 2, 3, 4, 5, and then back 1, 2, 3, and then a dash. So now I need to figure out what direction am I going to shade. Am I going to shade to the right, or am I going to shade to the left? Easy point to test is 0, 0. So let's test 0, 0 in here. So I'm going to have 0 is less than 5/3 times 0 plus 2, and I get 0 is less than 2, which is true. So we want to shade to the right, since this point 0, 0 is true in our inequality here. So I'm going to shade this in green for this entire section. And what is our solution? Well, our solution is where they overlap. And well, where do they overlap? They overlap right here. Right, that's where our yellow and green sections overlap, so that's where our solution is going to be. And if we want to test a point, we could maybe test a point like right on this line, since this line is a solid line, so we have to include the points on this line in our solution set. So we can maybe choose like this point. So this is going to be -3, -5. So let's try that point in our system. So we're going to have -3 is less than or equal to -3, which is true. And then in our second inequality, y is less than 5/3 times x plus 2. We're going to get -5 is less than 5/3 times -3 plus 2. -3 and 3 are going to divide out, so we get -1. -5 is less than -5 plus 2. And we get -5 is less than -3, which is another true statement. So our points check in both of our inequalities. This video was on how to solve systems of inequalities using the graphing method. If you like this video, leave a like, comment, and subscribe. This is Nick from First Coast Math Clinic.